Howdy. In part 1 of paper animations, I talked about making this basic loop in Cuttle. If you want to check out that video, the link is in the description. Today I'll be talking about making this structure, how it works, how to make one yourself, and how it relates to animation tools like a zoetrope. This structure is very much like a zoetrope, but it is not a zoetrope. A zoetrope is what people understand as being any spinning animation, but a zoetrope is a specific type of animation tool. It is a cylinder that has the interior has a series of animation frames. There are slits cut in the side, one between each animation frame, and you spin the disc and view through the slits. Because you're only getting a very brief moment where you can see each animation frame through the slit, you get a flash of the image, just a quick little bump, 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 and those quick little flashes create the illusion of motion and make it so it doesn't look like just one large blur, which is what it would be if you didn't have those slits cut in the side. This animation structure and the animation that you're seeing right here doesn't use the slits to break up the images. Instead, this structure, photograph it, rotate it slightly, photograph it, rotate it, on and on until I have 12 images, because that's the length of this animation. And then the playback that you're seeing right now on a screen is how the images are broken up. It's a series of flashing images that are happening so fast that you perceive it as motion. So these images are played in quick succession, and you see that circle moving up and down. In part 1 of paper animations, I talked about how Cuttle is structured and how to create this basic movement of a circle moving up and down within the frame of a rectangle. If you want to see how that's done, again, you can check out the description and a link will be there to the video. Let's get a bit less conceptual and look at this in Cuttle. Here is what the cut file looks like. There's a center shape that has 12 sides, and each frame juts out to the side and has a tab attached as well as a slit in the upper left of the frame. When assembled, the frames fold up and the tabs hold the frames together in a bowl-like structure. In order to make this form, I designed a Cuttle file that would place the frames of the animation equally around a center point. In order to do so, I had to break down this larger base shape into smaller components and use some math. In this project file, I have a component named frame, which is the animation I made in part 1. The width of the rectangular frame is 3 inches, and the total number of frames is 12, which is enough information for me to figure out the rest of the measurements for this cut file. To find the unknown measurements, I will use some isosceles triangles, right triangles, and trigonometry. In this animation structure, the number of sides is determined by the number of frames. This animation has 12 frames, which means that the structure and the base shape of the structure both have 12 sides. With a shape that has 12 sides with equal lengths and angles, you can break down the shape into equal slices like a pie. Because all of these slices are equal, all of their angles are also equal, which means all of these center angles together equal 360 degrees. And we can determine the measurements of one of these angles by dividing 360 by the total number of sides. The shape has 12 sides. 360 divided by 12 equals 30. So the center angle for each of these slices is 30 degrees. Using this measurement, we are one step closer to figuring out the size of this shape. These triangle slices are all isosceles triangles. An isosceles triangle has at least 2 equal sides and at least 2 equal angles, meaning it has a center line of symmetry. I need to find the height of this isosceles triangle in order to know the width of the 12-sided shape. An easy way to do this is to cut the triangle into 2 equal right triangles along that center line of symmetry. I mentioned earlier that each side of that 12-sided shape was going to be the width of my frame, which that measurement is 3. With this triangle cut in half, we can determine that this length is half of 3, or 1.5. We found this angle earlier by taking 360 divided by the number of sides of the base shape. 360 divided by 12 is 30. So we know that this angle is half of 30, or 15 degrees. We can now use the trigonometric function tangent to determine the length of this side using the formula tangent theta is equal to opposite divided by adjacent. Adjacent. There you go. This symbol is theta. With the right triangle, the non-right angles have an opposite side and an adjacent side. We're focused on this angle, so the opposite side is the side that is not touching either leg of this angle. So this is the opposite side. The adjacent side is the non-hypotenuse side that touches the angle, which is what we're trying to find. So in solving for adjacent, we need to adjust this formula. I'm going to multiply both sides by adjacent, which means that you have adjacent times tan theta equals opposite. Then we need to divide both sides by tan theta, which gives you the formula adjacent equals opposite divided by tangent theta. We have the value for opposite, which is 1.5, and we have the value for tangent, which is 15 degrees. So if you plug that into a calculator, you end up with adjacent equals a long decimal point, but approximately 5.6. We have a formula. Now let's implement it in Cuttle. I will be building from the project file I made in part 1, so many of my parameters are already established. You can find the project file from part 1 in the video description. First, I'm going to make a new component and name this Zoetrope structure. Now I'm going to add some new parameters. First, let's make a parameter called center angle. For this, I'm going to take 360 and divide it by frame num, which will give us that center angle for the isosceles triangle. Next, I'll make a parameter called radius. Here's where we will put in that formula we created earlier. In this parameter, we will put frame width divided by 2, divided by tan, left parenthesis, center angle, divided by 2, in parenthesis. Didn't capitalize that. Oh, I did frame width, which gives us approximately 5.6, which is the same that we established earlier when we did the formula. Now we have a radius for the base of our structure that will automatically adjust if we make changes to the parameters we have for frame num or frame width. Now let's look at this in action. First, I'm going to drag my frame component into this component. Next, I will change the origin to be x will be 0 still, but y will be frame height divided by 2. And that makes it so you can see this red little dot, that is the origin point. Now if I adjust the position, it will be based on the bottom edge of this frame as opposed to being the center point. Now I'm going to adjust the position, make sure that x is 0, and make the y value negative radius. And if I zoom out a little bit, you'll see that it falls higher up. Now I'm going to apply a rotational repeat by going to modify rotational repeat, and Cuttle defaults to having 6 instances, and we want to have 12, or more specifically, we want to have our frame number. So I'm going to go to repetitions and change this to frame num. Frame num. The bottom edge of all of these frames creates an equal 12-sided shape, which is the base shape of our structure. We also want to have the frames of this animation progress as they repeat. Right now, the circles are all in the same position. We want them to change based on what number they are in this sequence. So I'm going to come to rotational repeat, come down to customize each repetition, click that on, and that gives us a value that increases with each repeated instance. I'm going to change the name of this by double-clicking rep and changing the name to frame rep. Nothing's changed in the animation yet because we need to change the parameter. So click frame 1, go to time in here and change it from being 0 to be frame rep. And now you can see that this circle moves down, up, and back to the middle. Now we need to fill in this center area with a shape that follows this base structure that we have. I'm going to make this center shape by making a path with a rotational repeat modifier applied to the anchor point. So I will select the pin tool, and then if I click somewhere, now I have an anchor point, and I'm going to click out of this by clicking the select tool here, and now I have a path in this upper right, and if I do the drop down, I can manipulate this anchor. So for the anchor, I want to change the position of this to be negative frame width divided by 2, and I want the height to be negative radius. And that puts us in the lower left corner of our frame 1. Now I want to apply a rotational repeat modifier to this. So with anchor selected here in the upper right, I'll go to modify, come down to rotational repeat, and again it defaults to 6. I would like to have 12 of these, and if I should do this not as 12 but as frame num. Now I have one of these anchor points at each of the bottom left positions of every frame. And if I click the path, you can't really see it that well because this path isn't closed and it doesn't have a fill. So I'm going to, with path selected, come down to closed here, check that on, and then I'm going to click this to fill, and now we have a shape that fills in that center area. If I go in and adjust the frame number, everything adjusts and we have a shape that is moving up and down, and the frames are repeating the appropriate number of times, and the animation is increasing or decreasing with the number of frames according to all of our math. Let's go back to 12. I'm going to join these two shapes together by selecting both of them. You can do so by clicking and dragging, or you can come over here and select all of them in the shapes section. I'm going to go to modify Boolean union, and now you don't have that seam at the middle. So when you have the cut file, it'll just follow this exterior line. Now I need to add something that will attach the frames together and make the final structure. I'm going to use tabs that latch into slits. To do this, I'm going to first go into my frame component and then add some parameters for the tabs. So I'm just going to have these be parameters for this component as opposed to the project. First will be tab width, which will be frame width divided by 4. Then I'm going to add tab height, which will be 1 divided by 4. Then I'm going to add cut offset, which will be the distance the slit is from the edge of the paper, which I'm going to make tab width divided by 2. And then I'll add cut depth, and that will be tab height times 3 divided by 5. And finally, I will add one more parameter that is slit width, and that will be 0.03, and that'll be the width of the cut that is made into the tab and the frame. Let's add our tab. So I'm going to drag a rectangle into the scene, and I'm going to make the origin point be negative 0.5 for x, which puts the origin on the left-hand side of the shape. And then I'm going to make the y negative 0.5, and that makes it so the origin point is the upper left corner of this rectangle. So I'm going to then align this according to the upper right of the frame, which is frame width divided by 2, and the height is negative frame height divided by 2. And now our rectangle is sitting there. We need to adjust our scale. The x for this is tab width. The height for this is tab height. And now we have our tab. I would like to have this attach to my frame, so I'm going to go have this selected, go to modify Boolean union. And now I have a structure here. Now I need to add two slits, one into the frame and one into the tab so that they can connect. I'm going to drag a rectangle into the frame, make this change the scale to be slit width, and the Y value to be cut depth. And I'm going to change the origin to be, the Y value is 0.5, which makes it so the origin point is at the bottom of the rectangle now. So need to adjust the position of this. The position will be frame width divided by 2 plus tab width minus cut offset, and the height will be negative frame height divided by 2 plus tab height, and that gets our slit in the appropriate location. Now I need a slit for the tab to be placed into, so I will copy this rectangle by selecting the shape in the upper right, hit Command C, Command V. Now I have a duplicate that's in the same location called rectangle 4, and I need to change some of the variables in order to have it be in the correct position for this tab to be inserted into the slit. Change the X position to be negative frame width divided by 2 plus tab width minus cut offset, and I will change the Y to simply be frame height divided by 2 and get rid of this plus tab height. And now I need to change the Y origin to be negative 0.5, and now I have a slit in the top section. Now, the final thing that I need to do here is to cut those slits out of the shape. So I'm going to select all of these shapes and go to Modify and Boolean Difference. And now you can see that you have the tab with the slit cut into it over here, and the same slit cut over here, but from the top, which means that it'll latch into itself. And if I come over to Zoetrope Structure, it is updated here and everything is functional. You do run into a problem with this as it is structured, to where if you increase the total number of frames, you'll see that the tabs overlap. That's not an issue for me right now using 12 frames, so I'm not going to deal with correcting all of that, but it is something if you're using this as a base for a longer animation to consider. Just a few more things. How I will register this animation is I'll have a hole in the middle here where I'll put an upholstery tack. The upholstery tacks that I have a width of 0.06 inches, so I'm going to add a parameter here that is pinhole and make that 0.06. And now drag a circle into the area, and the position will be 0, 0. And change the scale to be pinhole, and then select everything in the upper right in the shape thing and come down to Boolean difference, and now I've got a little hole cut in the middle of this structure where I can place a pivot point and have it spin around. The last thing that I'm going to do is add a score line so that I can easily fold all of these frames up when I need to cut the thing out. So to do that, I want to trace that shape that I have in the center, and I'm going to grab that shape by coming to the path here, and I have that shape right here. I'm going to copy and paste that, and then I'm going to drag that path fully outside of this group, and now it's its own deal. So that I can distinguish it, I'm going to go to the path attributes and click off fill and change the stroke color to be red. So now if I deselect it, you can clearly see that line there. If you are using a cutting machine that has a score tool, you can skip this next step and leave this line as a solid continuous line. If you don't have a score tool, you can do what I'm about to do and make a dashed line. So select the path, go to Modify, and go down to Dashed Lines, and you'll see that now this path is a series of separate lines. I don't like to have this. I feel like it has too many cuts, which is both time consuming and weakens the joint. So I'm going to change this dashed line to be something slightly different. If you look underneath dash length here, you can see an annotation that denotes that the length of dashes and gaps along the path are equal by default, and if you adjust it, it will adjust both simultaneously. I want to have something where I have less of the dash and more of the gap, and in order to do that, you create an array. I'm going to establish the dash length and the gap length by creating new parameters. So create a new parameter, make dash length, and for me, I'm going to make this be 0.1, and for the next parameter, it's going to be gap length, and I'm going to make this 0.25. To create an array, you do bracket, variable, comma, variable, and bracket. So I'm going to do left bracket, put in dash length, comma, space, gap length, and then right bracket. And you can see that the dash line now has larger gaps between it, which means that you can use just a cut to cut here, and it'll weaken the joint to where it's easier to fold up. It takes a bit more time to cut, but it means that you have less tools involved. I have one final thing I'm going to do before I export this cut file to Cricut, which is make the cut file fit the paper size that I'm cutting. I'm using standard size letter piece of paper that is 8.5 inches wide on its shortest side and a Cricut Maker 3 to cut the paper. Cricut has a safety border for cutting that is 1/4 inch border on all sides, which means that I have a maximum cutting width of 8 inches. This shape is larger than that. I could do more programming to make sure that everything is restricted to that size automatically, but I'd rather just make a parameter that shows me the total width of the shape and make manual adjustments to get that down to 8 inches. One last parameter. This is just going to be showing me what the width of the shape is. The total width of this shape is going to be the radius times 2 and 2 frames. So let's just make a parameter, call it total width, and this variable will be left parenthesis frame height plus radius times 2, and currently the width of this is a little over 15 inches. I'm going to adjust the frame height and the frame width to change the total width. So if you have a variable in Cuttle and you click and drag to change the size of it, it will adjust according to the furthest decimal point. So I'm going to add a 0.0 to both the frame height and frame width, which means that if I click and drag now, it will adjust every 1/10 of an inch as opposed to every full inch. You can play around with this to see what sort of seems fitting best for you, and as you're watching, you can see that the total width is adjusting as I'm adjusting these heights. So I'm just going to play around with this a little bit. And I end up with a frame width of 1.4 and a frame height of 1.3. And if we look down at the calculation underneath total width, we have 7.8, which means that we are in the realm of cut area for the Cricut. In order to export this file, I will go to File, Export SVG, and you have a few options here. It'll default to standard. If you have not used this before, then there's Glowforge and Cricut. I'm using Cricut, so I'm going to export an SVG for Cricut, hit download, and it defaults to going to my download folder. Open up Cricut Design Space, create a new project, go to Upload, upload your image, select your image, put it on the canvas, and by default these are grouped. I'm going to right click on group, and right here you can see that this cut line is the score line. If you're using a score tool, you would come here and change the operation from cut to score. And I'm going to select all of these and click attach, which means that any action will happen on the same piece of paper. Select make. I'm not going to save this. And then if you go to material size, 8.5 by 11, it clears it by a little bit of room. And then hit continue. And I use the base material of medium cardstock, which you can find by doing browse all materials, medium cardstock, 80 pound. And the only tools that I'm using are a cut blade, so load in my mat and then cut it. If you opted to use the dashed line instead of a score tool, this will take longer to cut because it will cut, lift up, move, cut, lift up, move, and it takes longer. Once the cutout is done, I take the excess paper and remove it. Then I like using these curved tweezers to lift and separate the more delicate sections of the cutout before lifting the full structure off the cutting mat. Now that I have the cutout fully off of the mat, I'm going to fold up the frames along the score line. Do that for all the frames until all 12 have been folded. Now I'm going to lock the tabs in place by sort of bending each frame and positioning it under the tab until the slits align. Then repeat around the full structure. Bend the frame, line up the stills, then lock in place. The structure is now complete. To photograph the structure, I'm going to take this upholstery tack and a piece of masking tape to make a pivot point. Poke the tack through the tape, pointy side up for the tack, sticky side down for the tape, and adhere it to your surface. Put the pinhole that we cut out from the structure onto the tack. I like to somehow mark the structure so that when I'm photographing, I know when I've made a full loop. I'm recording this animation on a cutting mat that has a grid, so I will choose a point to line up the structure as I rotate. If you are not recording on a surface such as this, you can make a mark with a pen, pencil, tape, etc. to line up the frames. I use a remote shutter release to take each photo. This is a wired remote, which is my preference because you plug it in and there are never any complications with pairing the remote or dealing with dead batteries. Now that the structure is in place, I will take a photo. Then I will rotate the structure to where the next frame lines up with my alignment point. Then I will take another photo. Then I'll rotate, align, take a photo, again and again until the mark I made on the structure is back where it began, and I have taken 12 photographs since this is a 12-frame animation. And now with playback, we have a looping animation. You can see both the structure rotating and that circle moving up and down. This is just one approach to creating zoetrope-like animation structures, but now you have a formula which helps you solve a missing side for a right triangle, which is a more powerful tool than I thought it was when I first was starting into it. If you have any questions about what happened in this video, throw a comment question down there and I'll do my best to answer it. If you want to see more of this stuff, like and subscribe. If you want to watch me streaming, I try to stream Mondays through Thursdays, 3 p.m. Eastern Standard Time. And if you would like, you can watch those after the fact. There's a bunch of them recorded and available if you go to the live section of my YouTube channel. If you like the music in the background of this video, I made it and you can listen to it anywhere you stream stuff. Should be available if you just search for Trace Loops. And if you want these specific song names and time stamps, those are in the description. If you want to support me on Patreon, you can do so by going to patreon.com/traceloops, where you will find high resolution versions of artwork. You'll also find a selection of older tutorials, and at higher tiers you can find all the music that I made available for download, and at the highest tier you get monthly artwork from me in the mail. Adios.